Okay, so I'm coming to 1.7, finding the equation of a line. This one, this session is really important to, to a business class. We help you set up the equation of something like supply demand function or cost function, something like that, right? So I would like to skip page number 1 for now, because I think this is going to be it's supposed to be moving. Let me say, move this. Move this page. Next. Okay. So now, we're gonna move to this second, the next page first. Okay, so sometime you guys should understand that we're gonna have convenient to assume that the relations between the relation is linear, so that one can use incomplete information to make estimate. So the idea of interpolations is to find the value in between the data points we have been given. So we want to have some things informed as known and unknown. Okay, in order pairs at known, comma, and unknown. Okay, so let's start with example 1.24. And in here I have I given the following portion as the size of the curve and the cost of that, right? Size of the curve and cost of that. And in here, we stick with the question in this example that what should we charge for a 14-ounce cup, which means the known thing, right? The size is given, and we want to find the unknown. Okay, unknown. What is charging? So I would say size is a known things, and the charge in here is let's say the cost. And we know some given from the given information, we can set up 2 points as 12, 3.80. Okay, and 16, 4.40. All right. Okay. So we want to know, is there any way we can find for the case at 14 ounce, what the cost may be? Okay. You must start with thinking that using price demand equations, using the linear function as slope in the set form. Okay, so I'm going to set up function S. So I want to say the cost inside you're gonna use as say x and y you want, or maybe s and c, like that. Let's do as x and y. All right. So so we're gonna write as y equal to x plus b. Since I consider this as a linear function, so I'm gonna set up this as mx plus b. Okay. So the slope will be m equal to y2 minus y1 over x2 minus x1. So then you have y2 in here is 4.40 minus y1 in here is 3.80. And you divide by x2 was 16 and you minus 12. Then you have slope will be equal to 4 point. Let me see. Using the calculators. Okay, so using this was calculators. So say 4.40 minus 3.80. And divided by parentheses. 16 minus 12. So I get 0.15 at the slope. So 0. Okay. Crash. Stresses. And then we 0.16. Oh, sorry, 15. It's at a slope, right? So so in this case, now you can let's box this one at the side. You can substitute m equal to 0.15 into the function. The function. We have y equal to 0.15 plus b. Yeah. So then you will now just have to find what is b gonna be. All right, you need to find what's b gonna be. I will we need to find b because you want to have the functions in form as y equal to mx plus b is 0.15 x plus with b value. We need to find b value right now because we have m already, right? So how to find b? Okay, in order to find b, I'm gonna use the other color. You're gonna plug in 1 point. Okay, 1 point from the given. Any point, okay? 1 point from given. 2 points in given. So you can either choose this one or this one, all right? You can either choose one of them, okay? So I'm gonna choose the easy one, such as 12 and 0.80, 3.80 even. Okay. And now I'm gonna have using 12, comma 3.80, substitute in there. So keep in mind that this is the X value and this is Y value. Okay. And now what I have? I have 3.80 equal to 0.15 times 12. And plus B. We don't know B, right? So then B equal to and let's simplify it first. Right? $3.80 going to equal to 0.15 10 with 12. I have 1.8 plus B. So then B will be equal to B will be equal to 3.8 minus 1.8. Okay. 3.80 minus 1.8. And B will be equal to 2. B equal to 2 in this case. Okay. So I found B, I found M, right? I can come back to the general form of the slope intercept form. And I just substitute B into it. Or I mean, I can come back from this form. Okay, now I can have the function is in the form as y equal to M is 0.15x plus B is 2. Okay. So I will use a box to block this like this. Okay, now I will use this function to find the values of the cost when I have sine equal to 14. So A, if sine is 14, then we have x equal to 14. And we can use y equal to let's right, it's down here. Y of 14 will be equal to 0.15 times with 14 here, plus 2. And thus you can just use calculators and calculate that. Yes, and thus you get 4.10 ratio. So 4.10. 4.10. In my that it is a cost. So in 4.10. So that means the price supposed to be price will be 4.10 when size is 40 pounds. Okay, what about B? What should we charge for 15 amps? So if size is 15, which means X equal to 15. And we have Y of 15 will be equal to 0.15 times 15 plus 2. And use calculators, you must get $4.25. So basically, for this kind of problems, we need the function, right, to estimate with missing information. Okay, so now down here is a graph of the price in dollars and the size in amps, right? A graph of price functions in terms of size. As you can see, look at graphically right now, we can go up to 16, and at 16 there, you know that it was 4.4, right? If I ask about 14, right, see that you can make a vertical line from 14, map it to the graph, and then find the coordinates price. And in here, it's supposed to be 4.1, right? 1. And if you want to find the 15, make the 15 here and map it to the half here. And it's supposed to be this point. And you can see it's about like 4.25. So that is a way we do to estimate by graphing. You can actually go even more and further than that in the future. Let's say you make the size bigger, right? You can also using this graph to estimate the price supposed to be, or the size supposed to be for for the missing informations. Okay, so now I would like to move back to the cost problems here. Okay, and in the cost problems here, I also set up with the order pairs as number of cell phone first and the cost as the output. So we have 2 points from the given, and 2,000 cell phone give us 600. So 20,000 cell phone give us 600,000, and 50,000 cell phone give us 1,000. I mean, cost about 1,000. 1,050,000. Right? So so we're gonna using the linear model for the total cost as C equal to Vx plus F to produce X cell phone in terms of fixed cost and per diem cost. Fixed cost is labeled F, and per diem cost labeled at V. I mean, so keep in mind that we need to find the slope. And as you see right now, in the form and slope intercept form, the V here is actually the slope, or the variables of per diem cost is actually the slope. So we have slope will be equal to V, and will be equal to, using the formulas as usually in the form as y2 minus y1 over x2 minus x1, right? But since y2 in here is actually using the cost, so I'm gonna use as C of x2 minus C of x1, right? Because the cost for the y right now, and the bottom stay as x2 minus x1. So if you label bottom here at the C2, you're gonna write as 1,050,000, and you minus for 600,000, and you divide by 50,000 minus for 20,000. So then you're gonna have slope V, and using the calculators, you will have top one be 450,000 divided by 30,000 at bottom, right? And that's give us 15 for the variables, for the per diem cost. So plug into the linear model. We have C equal to 15x plus F. Okay, so now we missing only F. We need to find F, right? We need to find F. Okay, we need this one, right? So how to do that? Like we did before, we're gonna move into step using plug plug in any point. Any point from given to solve for F, right? And you see right now, we have 2 points. You can either go by 20,000 and 600,000 or the second one, 50,000 and 1 million something. I would prefer using the first one because it's smaller number. So I mean, you can use this the second one you want. Okay, so choose. And plug in the linear model. Okay, so plug in the linear model now. So we have this is X and this is C, right? So we have C now change to be 60,000, right? Equal to 15x. Is it 60,000? No, 600,000, right? 600,000. 600,000. And then 15 times with 20,000. And then plus F. Then I solve F by, no, let's just simplify it. I have 600,000 equal to 300,000, right? And then plus F. So then I have F will be equal to 6. So no, 600,000 minus 300,000. That's gonna be 300,000. Yeah. So then I'm gonna write out here. Therefore, the linear models is, okay, so let's move up a little bit. You can write as C of X equal to no, I need to have more space. C of X equal to V of X was 15x plus with F was 300,000. Okay, so then yeah, so then we did have this guy. Actually, you know, we need to just circle for you know what? No, actually, I'm gonna delete this one because but I just need to find only F and V. Right? So F equal to 300,000. Okay. Equal to 300,000. V equal to 15. So use the cost equation to calculate. So then cost equation is we have C equal to 15 x plus F is 300,000. And then block, because we have like 22,000, so X equals to 22,000. Into it. We have C equal to 15 times with 22,000 and plus 300,000. And that will give us 630,000. We try to calculate this as the cost of 22,000 cell phones. Okay, so this is a way we set up the function of the cost when we are given 2 points, and you see that, right? Similar with the one before. So I'm gonna left the exercise 1.18 for you guys to practice, and can give you the answer key for F and B. Say F when we go to, let me actually type it as, say F will be equal to 1,500 and V equal to 6. You can try that to find out, okay? And the answer key part B gonna be 16,200. Okay. So that's gonna be you can practice on this one, okay? Now we're gonna move down to the next examples as sensor data. I need one more column for you guys to practice with us. Okay, so let's see. Okay, trying to find, I try to set up in the form, in an order form as known and unknown in here, right? So let me say known, unknown. And then we have known in here will be, let's see, what is a known in here? Yes, yeah. So look at the question. Estimate the population in April something. So this is the given. This is a known. Right? And unknowns is the one that you are estimating. Right? Okay. So you can start with findings, maybe stating, let's see, the populations, so the, I mean, the known in here will be the year past 2000. So year past 2000. Years past 2000. and then the unknown in here going to be the population. So according to the given information, you say I have like April 1st, 2020. So how many years past 2000? No, nothing's past that. I mean, just zero. No years past 2000, right? Population was 162,954, right? That was 1 point. The next one gonna be 2010 is 10 years after 2000, right? 10 years after 2000. So or 10 years since 2000. So it's gonna be 144,186. Yeah. So now, we have 2 points. We have, we can find a slope of these 2 points, but let's label this as, I mean, we can use X and Y again if we want, right? So let's say X and Y. So Y stands for population and X stands for the number of years in 2000. Right? So I'm gonna go ahead and find the slope. All right. Slope will be equal to y2 minus y1. So I am using y2 is 144,186 minus for the 162,954 divided by x2 is 10 minus 0. So the slope will be 18768 over 10, and that's going to be equal to 1,876.8. Yeah, this is like unit gonna be like people in the years, something like that. But we don't really need it right now, right? So we have slope, use other colors, substitutes m into y equal to mx plus b, right? So we have y equal to 1,876.8 x plus b. So we need to find b now, right? I'm gonna move a little bit this guy to here, maybe up to here. So now use other color, let's say this one. Let's find so I'm trying to find the b. So let's the next step is substitute a point to solve for B, right? So let's choose a point. I could always choose the easiest spot as 0 and 1, 162,954, right? So use 0, 162,954. Then we have 72 into that, you have y equal to 1876.8 time with 0, right? Because that's right now change to be 0 plus b. I forgot to change to 72 for y. That's 72 for y. Gonna be 16,2,954. So then b will be equal to 16,2,954. Okay, we can substitute b but into the equation. We have y equal to 1876.8x plus 162,954 for b, right? So we did have we did have the equations for these populations functions, right? And now we just need to estimate the populations on April 1st, 2019. So on April 1st, so April 1st, 2019, we will have x will equal to 19, since we have 19 years since 2000, right? So then we can substitute x equals to 19 into the equation. We have y equal to 1876.8 times 19 plus 16,2,954. And that will give us as 161,077 as the answer. Okay, so that's gonna be the answer for this problem. And I can say like the population should be about 161,077 after, okay, we on April 1st, 2019. Okay, so so that is for this example 1.25. You can go ahead and try the similar one over here to find the CDU is by populations. The answer key for oh, I think I forgot to do this one. I forgot to do part A. Okay, so here's part B. And part A. I need to substitute. Substitute x equal to 15, right? Because 2015. So then we have y equal to 1876.8 15 plus 162954. And that's going to be about one. Let me check it, sure. Oh, I made a mistake here. I made a mistake here. I made a mistake here. It's supposed to be 20. So then fix this. Yes. This one is 20. This one is 10. Oh. That will be huge things. Okay, so let's see. Okay, so we must have 10 and minus 20. This is 19. This is never possible. This is only possible. That's look good for now, but that's one. Then I'm gonna put down here 20 here. So there. I will not have b equal to this, but I will have b equal to 125. 418. Okay, so that's gonna be the b. Okay, now I think this one 125 418. Okay. So then this one's so much. My answer key is still okay since I did it before. Okay, so suppose to be 161077 for part B. For part A, this should be channel so 12548. And you get 153,570. Okay, so that is for part A. Yeah. Yes, bye. All right, so I will say we need more space for this. for A, especially for A, maybe before this. To set up. Actually, we're gonna say need more space for that. Right? Okay, so now we're gonna skip this one, and I mean I'm gonna skip this one. I give you the answer key for that. Estimate the number of undergrads in 2021. So gonna be 10,462. And this one with 10,992. Okay. Okay. So try that. Try the way I show you, okay? So I'm gonna show you quick on this one, right? So again, we're gonna set up known and unknown in here. Look at the question, right? So if its value depreciate linear for tax from 20,000 to 2,000, what would be the value of the equipment after 6 years? So that means this gonna be no. I'm gonna say years, right? And values gonna be is the unknown one, because we want to find the values, right? So we need to have 2 points. Let's label year as T, values maybe as V. Okay, so we have the first one was okay, so they say office equipment was purchased for 20,000 and it's assumed to have scrap value. So at first value was 20,000, right? So how many years at first? You just buy it, so you didn't use anything, just say 0 years, right? And then you have the second part gonna be like 10 years and 2,000 as the values. All right. So then you want to have slope as V2 minus V1 over T2 minus T1. So V2 was 2,000 minus 20,000 divided by T2 was 10 minus 0. So you have negative 18,000 divided by 10, and that make negative 1,800. So as you see that the slope is decreasing. I mean, the slope was negative, so that make a decreasing line. So that's Okay, so now I'm gonna have this. I'm gonna have this function at v equal to mt plus b, right? Mt plus b. So we have slope already, so we can say v equal to negative 1800 times t plus b. Okay, I plug the point into it. Gonna choose the easiest one. One was 20,000 into the equation. And we have 20,000 at v equal to negative 1800 times zeros plus b. Then we have b will be equal to 20,000. So then we have v will be equal to negative 1800 times t plus with b. And now b is 20,000. Okay, and after 6 years, mean that t equal to 6. Then you have v will be equal to negative 1800 times with 6 plus with 20,000. That means v will be equal to 9,200. So that means these are values after 6 years of the item that of the equipment that we purchased. Okay. Similarly, you can work on the depreciation in 1.20 there. Okay, so I'm gonna skip this one and let's see what I think about that. Now let's move to the next problem, 1.27. A company manufactures and sells X toaster oven per week. The weekly price, demand, and cost functions are P of X equals to 80 minus 2x, P of X equals to 600 plus 5x there. The revenue function is gonna be X and P of X. And I can check, I can substitute, keep my desk. I did have P of X in here equal to 80 minus 2x. So I can change it to P of X as X times with 80 minus 2x. So then when I simplify this, I'm gonna have 80x minus 2x squared. All right, so I mean I can distribute it like that, right? So this will be the function of the revenues. Okay, revenue function. And if I draw the cost functions, I can have as 600 as the fixed cost here. I have 1 point, and I need one more point. I can choose 40 here. Say CF 40s will be equal to 600 plus 5 times 40s. We will have we will have 600 plus 800. And then we have C of 40s will be equal to 1,400. So 1,400 is kind of like like a higher than like over there, right? So I must try to use the different number, I think. That's using. Let me see. Let me see. Uh-oh, I make a mistake here, sorry. It's supposed to be 20, 200 here, right? Oh, that's why. I thought this was correct. Mistake. That's here. Then I have a point was 40 and that's 40 common items. And fixed cost was 600 there, so I just draw the line. So this one's better. So I have cost function there. At the cost function, and I label it as CX here. And I want to add in the break-even point. So break-even point. Break-even point is the point that's when the cost and when the revenues they equal each other. So let me relabel this one. Pass again. Okay, so something was really it's crashed all things. Anyway, I would love to stop these here because this is kind of like it is not really into these topics as set up the equations. So I'm gonna stop section 1.7 at here. And I will see you in the next section. Okay. I will talk more about that later.